All right, so in this lesson, we are going to be learning the difference between elements and compounds and also learning how to interpret chemical formulas. So prior to viewing this video, you should download the copy of the periodic table of the elements that I have put on my website. You will need that periodic table as we go through this unit. So in grade 7, you learned about the particle theory of matter, and I would draw your attention to the textbook section 5.1. You should review that, that it was taught to you in grade 7. But just a quick review, particle theory of matter. All matter is made up of extremely tiny particles. Each pure substance has its own type of particle. Particles attract each other. The particles are always moving, and particles at a higher temperature move faster than particles at a lower temperature. So all matter is made of particles, and we are going to be learning about two specific types of particles in this unit, namely the particles that make up elements and the particles that make up compounds. Grade 10 science, you'll learn more about the compounds. We're just going to introduce the particles today. So an element then is a pure substance. You cannot break it down chemically, and you can refer to your periodic table of elements here that you downloaded, and there are about 118 natural or known elements, and they're always discovering more, but this table here shows 118. And so we'll be learning more about how this table is organized, but you should be drawing your attention to a few things. Number one, every element has an atomic number. So that element number is on the top left. It has a mass number on the bottom. There is a name. So every element has a name, and every element has a symbol. So you need to know the first 20 element names and the first 20 element symbols. You should commit those to memory. All right. So all matter is made of atoms. These atoms are the special particles that make up matter that you learned about in grade 7. An element is a pure substance. Okay, so it's homogeneous. You cannot break it down. And an atom then is the smallest particle of an element that contains the properties of that element. And we'll be talking later on about physical and chemical properties. So we're going to move away from elements and talk about compounds. So some matter is made up of one element, okay, but most matter consists of two or more elements that are combined, chemically combined, and we call these compounds. All right, and so the smallest particle of a compound that shows its properties is called a molecule. And so where elements have element symbols, we use chemical formulas to indicate the molecules. So for example, we have names for molecules of compounds. So when we burn magnesium, magnesium is a metal. So if you burn magnesium, it reacts with oxygen and it forms a white powdery substance. We call that compound magnesium oxide. So that's the chemical name. And in grade 10, you're going to learn about chemical naming, not in grade 9. So instead of writing out the names of compounds, we use element symbols to write a chemical formula for the compound. A chemical formula shows the type and number of each element in the compound. And so we have a formula for magnesium oxide, it's MgO. And if we refer to our periodic table, Mg is magnesium, O is oxygen, so magnesium oxide. Again, in grade 9, we're not going to be concerned about how we make these formulas. You'll learn about that in grade 10. All you have to know about in grade 9 is how do we interpret this formula. So can we tell what elements are in there based on the symbols and the numbers of elements in each compound and the total number. So the formula tells us two things. One, it tells us the elements that the compound is made of, and that comes from the element symbol. So I'll put this in red, refer to the element, to each element symbol. And how many atoms of each element make up a single compound, and that would be the subscript number. Okay, so subscript again, is the little number that goes underneath. So for example, here, MgO, there's no numbers written, so we would assume it's 1. If there's no number written, we assume it's 1. So there's 1 Mg and 1 oxygen. So if we take a look at a very familiar compound, water, okay, the formula for water is H2O. So I'll write it out again here. Okay, make it a bit bigger. So water is actually okay, so water is the formula H2O. So you can see that there is a subscript 2 with the H and there's no subscript with the O. So that means that there is 2 hydrogen atoms and there is 1 oxygen atom. So if we wanted to find the total number of atoms, it'd be 2 plus 1, which is 3 atoms in 1 water molecule. So we get the 2 from the 2 there, that's the subscript, and we get the 1 from the 1 that's not written, but it's assumed to be there. And we know it's hydrogen and oxygen because H is hydrogen and O is oxygen. So that's how we know. And we've just interpreted our first chemical formula. So some examples here we'll go through for you. So I would give you some different chemical formulas and you would interpret them by indicating number 1, what are the names of the elements and how many atoms of each element are in a molecule and then how many are in total. So if we look at this formula here, NaCl, by the way, NaCl is sodium chloride, which is table salt. Just a little information piece for you. Okay, so what we will do then is go through and analyze this. So the first element we see is Na. So we go to our table and we find it and look carefully at it and we find Na. Na is sodium and Cl is chlorine. So we have sodium, and we have chlorine. So how many sodium atoms do we have? Well, there's only 1. And how many chlorines do we have? 1. So total would be 2 atoms in 1 NaCl. There'd be a total of 2 atoms in the NaCl molecule. All right, the next example is N2O3. So we look for N and O. We should already know, hopefully, that O is oxygen, but we can confirm O is oxygen and N is nitrogen. So we have nitrogen and we have oxygen. So the subscript numbers, we have 2 nitrogens and 3 oxygens. It's pretty straightforward. So 2 atoms of nitrogen, 3 atoms of oxygen. And so for a total number of atoms, 2 plus 3 would equal 5 atoms in total. All right, so we go to our next example here, just looking at some different formulas. We have KHCO3. This is known as potassium bicarbonate. We have now a few more atoms. Okay, we have K, we have H, we have C, and we have O. So K is potassium. H is hydrogen. Again, as you go through this more often, you'll memorize it. C is carbon. And O is oxygen. So we have 1 atom of potassium. We have 1 atom of carbon. We have 1 atom, of hydrogen. We have 1 atom of carbon, and we have 3 atoms of oxygen, for a total of 1 plus 1 plus 1 plus 3, or 6 atoms in total. All right, moving on. FeSO3. Clearly, we can see we have 3 different elements. We have Fe, okay? We have S, and we have O. Now notice that we have 2 letters here in the symbol, Fe. One is capital and one is lowercase. So little e is not any element. You'll never have a lowercase letter. So if you notice 1 capital and 1 lowercase, like Fe or Mg, that would be considered 1 element, versus So is not 1 element, okay? You never write an element with capital S, capital O. S is sulfur, O is oxygen. But Fe, if we look here right in the middle, is a very common metal, is iron. In fact, it's the most abundant metal in the Earth's crust. We have iron, we have sulfur, and we have oxygen. From the formula, there's 1 atom of iron, 1 atom of sulfur, and we have 3 atoms of oxygen, yielding a total of 5 atoms in this molecule. 1 plus 1 plus 3. Again, we don't see a subscript number. We assume it's 1. Okay. Example 5, something that you guys like very much. It's glucose. So it's a sugar, not sucrose that you have table sugar, but glucose. If you've ever eaten honey, okay, you've most likely eaten glucose. So glucose, C6H12O6. Okay, it's interestingly also the product of photosynthesis. Okay, plants use sunlight to make glucose from carbon dioxide and water. So that's very important for us as animals, because our cells need this glucose to keep us alive. Remember, the mitochondria in our cells burn glucose to provide us with energy. So we have 3 different elements in this. We have C, H, and O. So carbon, we have hydrogen, and we have oxygen. So there are 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. So a total number, 6 plus 6 plus 12, would be 24 atoms in 1 molecule of glucose. Okay, this last example, actually I'm going to give you guys 1 more, but this last example here, the formula you'll notice looks a little different. It's got this bracket and a subscript on the outside. So the way this formula is interpreted is that whatever is inside the brackets, we have 2 of them in this case, because the 2 is the subscript number. So there would be 2 oxygens and 2 hydrogens, because this formula is basically 2 of these bonded to the Mg. So for a grade 9 student, all you need to do is say, okay, for the total number of atoms of each element, I just take the number on the outside and multiply it by the subscript on the inside. So I'll show you how we do that. So we've got magnesium, we've got oxygen, and we've got hydrogen. Okay, so it's pretty straightforward. For magnesium on the outside, there's only 1 of them because there's no number written, so 1 atom. Oxygen, all right, on the inside we have 1, okay, because there's no number, and we're going to multiply that by the number on the outside, which is 2, which is 2 atoms. Okay, so that's how that works. Hydrogen, same thing. We look on the number on the inside, there's no number there, so that's a 1, because we assume it's 1. Multiply it by the number on the outside, which is 2, which is 2 atoms of hydrogen. So we have 1 magnesium, 2 oxygens, and 2 hydrogens. So for a total of 5 atoms. Okay, so I'm making up example number 7. You might see a formula like this. Okay, so if you see a formula like this is copper sulfate, and you notice that there is water here, H2O. This is called a hydrated compound, which just means that water attaches itself. So when we interpret the formula, we actually have to interpret the whole thing. Okay, so there's 2 parts to the formula. There's the first part, CuSO4, and then there's the second part, 4H2O. And so the way this works is that we still interpret each one, but you notice here there's a 4 in front of the H2O. That 4 you multiply by both subscripts. So 4 times 2 would be 8 hydrogens, and 4 times 1 would be 4 oxygens. But notice that oxygen appears twice, so you'd have to add the total, add them to get the total. So working left to right, we have copper. And again, we know that because we go to our periodic table and we would find copper, Cu is copper. We have sulfur for S. We have oxygen for O, and hydrogen for H. And oxygen does appear twice, but we don't need to write it the name out twice, just once. So copper, there is 1 atom. Sulfur, there is 1 atom. Oxygen. So we have 2 parts of oxygen. We have the O4, so there's 4. And then we look over here, okay, 4 times 1. That would be 4 plus 4. I'm writing it all out, but you can do that in your head, I'm sure. Total of 8 atoms of oxygen. So again, here for the hydrated compound, if you see that times whatever the number is, H2O, you take that number in front and multiply it by the number on the outside. I'm sorry, the subscript number of O, which is always 1 for water. So 4 here, 4 oxygens there, so 8 in total. Hydrogen is only here, so there's a 2, so that would be 2, and then you'd multiply that by 4 because the 4 is in front, and that would be 8 atoms as well. So total in the compound would be 8 plus 8 plus 1 plus 1, so that would be 18 atoms in the formula. So this concludes the lesson on interpreting chemical formulas and noticing the difference between a compound and an element. Remember, an element is made of atoms, and the element symbols are on the periodic table. Compounds are consisted of atoms or elements, bonded together, and they make up compounds. Okay, and they have particles called molecules, and you will learn in grade 10 how we make these and how we make the formulas. And again, for grade 9, all we have to do is interpret the formula, state the names of the elements, state the number of atoms of each element in the compound, and state the total number of elements. And so after you go through these notes, there is a practice sheet that you can try, and there will be a concept check tomorrow.